LinkedIn presents.
I'm Rufus Griscom.
And I'm Caleb Bissinger.
And this is The Next Big Idea. Today,
the surprising science of animal intelligence. Are you a dog guy, Rufus?
You know, Caleb, I like dogs. I was highly allergic as a child. And this caused me to become suspicious of the I feed you, you love me relationship. But then we got a dog, Paddington Q Dog, and I loved him. And now my kids are campaigning for a dog. We live in the city. I don't know what to do.
Well, you know, for most of my life, I shared your suspicion of dogs. I just found them, this is kind of controversial, but I just sort of found them to be annoying, right? Like,
I understand.
They bark, they shed, they roll around in dead stuff. And this kind of canine apathy that I've practiced for a long time started to cause some real problems for me when I moved in with a bona fide dog lover.
Yeah, it's tricky.
Like my girlfriend and I will go on walks together, and I would see a dog coming and start to cross the street. And meanwhile, she would like bolt ahead to go pet it. She just loves dogs. And after these encounters, she would come back and she'd remind me that like she really wanted to get a dog one day. And I'd tell her, oh, you know, it's pretty hard with our jobs or we don't really have room. But then came the pandemic and we found ourselves working from home in a dog-friendly apartment. And when she said,
I think we're ready for a dog,
I knew there was nothing I could do to stop her. So May 14th, 2020, which happens to be my girlfriend's birthday, we rescued a dog and named her Cisco. We knew very little about her. She'd been found wandering around in the high desert of Southern California. And the folks at the adoption agency said she was probably about 6 months old. So there I was, about to go from being someone who basically had no interest in dogs to being the nervous owner of a new puppy. Or at least I thought she was a new puppy.
If you have a dog between 6 months and 2 years old, you don't have, as commonly assumed, a puppy. You, my friend, have a teenager, an adolescent in a mature 30-year-old body.
That's Alexandra Horowitz, speaking in the book bite she made for the Year of the Puppy. Alexandra is a dog savant. She runs the Dog Cognition Lab at Barnard College. One of her previous books, Inside of a Dog, spent 65 weeks on the New York Times bestseller list, which, by the way, is 15 dog years. And as I listened to her book bite recently, I had this strange feeling like she'd snuck into my apartment and watched our first few weeks learning to live with Cisco.
Just like the human teenager's sometimes erratic behavior, distant and argumentative one moment, really sweet the next, teenage dogs can be disobedient, seem to seek conflict, and also be clingy and stick by your side.
Teenagers, whether they have 2 legs or 4, are sailing through a hormone storm. And in the long term, those hormones lead to sexual maturity. But in the short term,
their brains are being rewired, especially in areas regulating emotions and making judgments. But if an adolescent dog suddenly refuses to come when called, people are disposed to say, oh, you're a bad dog. Not, correctly, oh, you're going through a phase. This is a problem because a primary reason for returning or giving up a dog is their behavior. They jump, bite, escape, soil the house. And with the uptick of these behaviors in adolescence, there's a severe uptick of relinquishments.
I've got to say, I really wish I had known that when we rescued Cisco, because there were definitely times where I thought, you're a bad dog. Actually, I didn't just think it. I told her, oh, you're a bad dog. You know, we never considered relinquishing her, but I'd be lying if I said there were not moments, like when she ate all 4 corners of a rug, that I regretted getting her. Raising a teenager is exhausting.
I can confirm this, Caleb. We have a couple Homo sapien teenagers at home, not for the faint of heart.
Yeah, I mean, my girlfriend and I, we would just keep asking each other, like, is she ever going to chill out? And we should have been asking Alexandra Horowitz that question.
It is only a phase. And it's hard for them too. It's been likened to being like waking up in a tent in a hurricane. Realize that, and it's easier to release your vice grip and worry about this mischievous scamp in your midst.
We've now had Cisco for almost 3 years, and unsurprisingly, Alexandra was 100% right. The teenage naughtiness was only a phase. Cisco eventually became less of a rascal, less exasperating. And as that happened, my apathy towards dogs.
Sometimes I'll hear Caleb say, "How's your day going?" And I'll wander in to answer, but I find him lying on the floor, whispering into Cisco's ear, wondering how her day is, giving her sweet kisses, and I realize that he's not wondering about my day at all.
At age 30, I discovered what dog lovers have known for millennia, which is that dogs are an endless source of affection and humor and companionship. And now that I've fallen head over heels for my dog, I find myself increasingly interested in animals of all stripes. You know, we know that animals are vital to the environment. We know that they're vital to the economy. I actually read this fascinating estimate that pollination from honeybees delivers $500 billion to the global economy every year. Wow. So we know that, and we know that, you know, if we can't figure out how to put climate change in check, 1/3 of all animal species could be extinct by the end of the century. What I didn't know until I listened to a few recent book bites, and for listeners, that's what we call the 12-minute book summaries that top nonfiction authors make exclusively for the Next Big Idea app. What I didn't know until I listened to those is that animals don't just need our protection, they deserve our respect, because animals are brilliant. And so today on the show, Rufus, I want to play you excerpts from a few of those book bites. I'm going to introduce you to slime mold that can outwit the smartest human engineers. We'll hear field recordings captured by scientists who are learning how to speak with 45-ton sperm whales. And we'll meet a cognition researcher who makes the case that the way animals think may actually be superior to how we humans do it.
I love it. As you know, Caleb, we aspire to humility here at the Next Big Idea Club. And I think species-level humility is something we could use a lot more of.
I'm Kwame Christian, and I am the CEO of the American Negotiation Institute, and I want you to check out my podcast, Negotiate Real Change. Listen to conversations with leaders in the diversity, equity, and inclusion space, and learn the secrets behind what it really takes to become a successful advocate, ally, and change maker in your organization. Check out Negotiate Real Change on your favorite podcast player.
So, Caleb, what's up first?
Okay, so the first book bite I want to play for you is from a book called Ways of Being by James Bridle. James is a writer and artist, and in the book, he surveys all these different non-human modes of thinking. And he concludes, this is a quote, that by expanding our definition of intelligence and the chorus of minds which manifest it, we might allow our own intelligence to flower into new forms and new emergent ways of being and relating.
Ooh, I can't wait to hear that. Let's listen to the book bite.
Everything is intelligent, and there are many ways of doing intelligence. Humans are really bad at recognizing the intelligence of others because we tend to define intelligence as what humans do. But when we start to think about the world from the perspective of other beings, their abilities start to become clear. For an example, consider the gibbon. Gibbons belong to the same class of large-brained mammals as chimpanzees, bonobos, and us, so we should expect them to be able to solve the same kinds of puzzles. But for years, gibbons failed all the classic tests of intelligence, picking up cups to look for treats underneath, or using sticks and poles to reach food placed outside their cages. So in the eyes of science, they appeared dumb. It was only when scientists redesigned their experiments, for example, by hanging the sticks from the ceiling of the gibbon's enclosure, that the gibbons sprang into life and grabbed their treats, becoming, in that moment, scientifically intelligent. Of course, they've been smart all along, but gibbons are arboreal. They live mostly in the treetops, and they expect their tools to be found above their heads. They have an arboreal intelligence, a way of thinking and being in the world which matches their bodies and environment. The more we think about how other beings actually live their lives, the more we find out about how they do intelligence. This can take many forms. Spiders store memories and plans in their webs. Prairie dogs call out the species and appearance of different predators, and bees dance the location of new nesting sites, and then vote on them. Everything is intelligent, and all these different beings have something to teach us.
And arboreal intelligence. I love that.
Totally. And it makes intuitive sense, I think, like this idea that intelligence is connected to environment.
Right. The extended mind, Caleb. We are intelligent in the context of our habitats.
Exactly. So that was James's first big idea. His next is, frankly, kind of bonkers. He says that plants can hear and remember.
A few years ago, researchers recorded the sound of cabbage-white caterpillars munching on the leaves of a cress plant. When they played the sound back to some other cress plants, they found that the plants responded in exactly the same way that they did to the presence of actual caterpillars. They immediately flooded their leaves with chemical defenses to deter the predators. Crucially, they didn't do this when they heard the sound of the wind or even different insects. They heard and recognized a particular sound and acted on it. We've long thought of plants as insensitive and immobile, but it turns out they're actively paying attention to the world around them, processing and storing information, and changing their behavior based on their experiences. In short, they're doing all the things that in animals we call intelligent. We can never know what it is like to be a plant, but we can understand that we share the world with them. We hear the same sounds, feel the same sun, and breathe the same air. We share a world, and so we can think about building better worlds together.
I think that's a really lovely call to action. Plants and animals aren't these inert, helpless things, as we normally think of them. They're intelligent creatures with whom we share the world, and it's myopic of us not to take their experiences into account.
Yeah, no, that's a great point. Okay, let's hear one more big idea from James's book bite for Ways of Being. This one will forever change the way that you think about mold.
I have to admit, Caleb, I think my impression of mold has room for improvement.
Slime molds are strange, unicellular little creatures, a little like amoebae, a little like fungi, which grow on old logs and forest floors. But they have one particular ability. They are very, very good at route planning. A few years ago, some researchers used slime mold to recreate the Greater Tokyo Transit System. They made a map with oat flakes, a slime mold delicacy representing city centers, and light and shadow marking rivers and mountains. Within 24 hours, the slime mold, Polycephalum physarum, had found the most efficient route between cities and around obstacles, a task which took the best human engineers decades. Slime molds can also solve harder conundrums, such as the traveling salesman problem, which asks us to find the shortest route between a number of cities, visiting each one only once. This is the kind of problem which people, and computers, find very difficult, because there are a huge number of possible solutions, and the problem gets much harder every time you add a city. But slime molds solve the problem faster and more efficiently than people do, and faster too than the most advanced supercomputers we've ever built. The thing is, this problem, that we and our machines find so fiendishly difficult, is just not that hard for slime molds. It's just what they do, because they do intelligence differently to us. Imagine what other things we could learn from them, and from other animals, plants, and whole ecosystems, if we could imagine the intelligence they possess differently and learn to ask them better questions.
So extraordinary. It's funny, as I was listening to that, Caleb, I kept thinking about this other book bite that I really loved.
Oh, are you talking about If Nietzsche Were a Narwhal?
Exactly. That's the one.
Yeah, I have some clips from that too. Maybe before I play them, why don't you quickly tell listeners what that book is all about?
Sure. So it was written by an animal cognition researcher named Justin Gregg. And he says his mission in writing the book was to get people to rethink their ideas about the value of human intelligence. Most of us believe, I think, that animal thinking is a less sophisticated version of human thinking. But Justin says it's time for us to question human intellectual exceptionalism.
I love this line of his, quote, "The way other animals' minds work often results in better solutions to living a good, happy life.
Yeah, this is something that German philosopher Friedrich Nietzsche figured out more than 100 years ago when he contemplated our uniquely human fixation with death.
Humans are likely the only species on the planet that truly understands our own mortality.
That's Justin, by the way, not Nietzsche.
Other animals do understand something about death. A cat or dog can learn the difference between a living creature and a formerly living creature that will never function again. But the human mind is unique in that we understand that a future is possible in which our body and mind no longer exist. We have the ability to imagine this scenario. What's worse, we can understand that this scenario is inevitable, that we will surely one day die. On one hand, that's useful information. It helps us plan our behavior to both avoid dying and provide for those that are still around after we die, like life insurance, for example. But knowing that we are mortal generates a lot of misery for most people. And the only way we can function without dwelling on our own mortality is through the ability to ignore this fact most of the time, to live in a kind of denial. Humans, then, are constantly battling thoughts of mortality, and it's a major contributor to things like anxiety, depression, and suicide. This death wisdom is unique to our species, and it isn't really all that much fun. There's a good argument to be made that humans are not better off with death wisdom. It's an argument that made Nietzsche jealous of non-human animals to some extent. That's why Nietzsche features front and center in my book. He's the poster child for how thinking too hard and too much about existential questions leads to a life of misery, a kind of misery that non-human animals don't have to deal with. Insight number 2, human morality is often less moral than animal normativity. Scientists now know that animals live by a set of unspoken guidelines for how to behave that we call norms. Humans have them too. There's a human norm, for example, that you can't just go up to a stranger in public and run your fingers through their hair. That would be weird. And yet, it's a rule that parents don't explicitly teach their children. It just automatically crops up in most cultures. This is similar to how norms work for animals. Chickens, for example, develop a pecking order in a flock that dictates who gets to eat first. Humans, however, have the intellectual capacity to think more deeply about norms and codify them in such a way that they become explicit. They are rules that we consider, think about, and evaluate. That's how we end up with laws, for example, or religious or philosophical doctrine explaining what is and is not allowed from an ethical perspective. We call these things morals, and they are unique to humans. The problem with morals, however, is that we can use complicated reasoning to arrive at a moral position that is reprehensible. A government or a church can justify genocide on moral grounds. It's happened countless times in our shared history. Animals, on the other hand, don't have the ability to transform their norms into explicit moral codes, which is exactly why animals do not commit atrocities like the Holocaust. Animal norms rarely lead to this kind of death, destruction, and suffering, which is why I argue that animal normativity is often better and less destructive than human morality. Insight number 3. You don't need to know why things happen to still make good decisions. Humans are unique in our ability to ferret out cause and effect. We are curious as to why things happen. Why, for example, we hear thunder just after seeing a lightning strike. Because of that curiosity, we would go on to understand that lightning rapidly heats the air and that the thunder is caused by the sudden compression of hot air. Animals are far less interested and usually incapable of these kinds of causal inferences. But so what? Most of the time, all an animal needs to know is that one thing often follows or precedes another. These sorts of learned associations give them knowledge of correlation, just not causation. And that's usually good enough. A dog can learn through association that thunder follows lightning, and that if it sees lightning, it should hide under the couch ASAP. A dog doesn't need causal inference or knowledge of how thunder works to nonetheless make a smart decision about hiding under the couch. Animals have been around for billions of years using only learned associations and not causal inference to make decisions on how to behave. And that has worked just fine for them. Don't get me wrong, causal inference is great stuff. It's how science was able to make most of its discoveries, like vaccines or germ theory or nuclear fission. But, as I argue in the book, some of these things are actually quite dangerous. Nuclear fission gave us the atom bomb, which is a potential issue for the survival of our species. So maybe causal inference is more of a curse than a blessing sometimes.
Be careful what you wish for. You heard it here first, folks. If you want to live a happy life, try to be a little less existential and a little bit more like a dog.
When we come back, we'll hear from a documentary filmmaker whose near-death encounter with a humpback whale led him from the waters of Dominica to the laboratories of Silicon Valley, where scientists and startups are on the cusp of figuring out how to speak to animals.
Stick around. We'll be right back.
Hey you, I'm Andrew Seaman. Do you want a new job? Or do you want to move forward in your career? Well, you should listen to my weekly show called Get Hired with Andrew Seaman. We talk about it all, and it's waiting for you, yes you, wherever you get your podcasts.
Hey folks, Rufus here. If you're a fan of our interviews with physicians, scientists, or entrepreneurs, then I have the perfect podcast recommendation for you, Raising Health. Previously called BioEats World, Raising Health comes from leading venture capital firm Andreessen Horowitz, A16Z. Each episode, Raising Health dives deep into the heart of healthcare, biotech, and AI with A16Z general partners. Along the way, they explore the real challenges and opportunities in health and biotech entrepreneurship. Not to mention, you'll hear raw insights and actionable advice from notable guests like Omada CEO and co-founder Sean Duffy, and AI expert and In-Sitro CEO Daphne Koller. Don't miss out. Follow Raising Health wherever you get your podcasts.
This is the moment that I almost died.
He knocked it over.
In 2015, I was kayaking in Monterey Bay, California, when a 30-ton adult humpback whale breached out of the sea and down onto me and my friend Charlotte. We had been in a whale-watching tour and were paddling back to shore when the whale erupted out of the ocean. It was shocking and incredible and beautiful, as if a living building grew out of the water.
Tom Mustill is the author of How to Speak Whale.
It crashed into the kayak and dragged us down. Somehow we escaped unharmed. For an animal the size of a truck to hurl itself out of the water, scientists have estimated they release an energy equivalent of about 40 hand grenades. Other kayakers came to our aid, and we paddled back to shore, thrilled to be alive and processing the extraordinary experience we'd had. I didn't realize we'd kayaked into a seismic change happening in biology.
Tom is a wildlife filmmaker. In the last 15 years, he's worked with the BBC, PBS, National Geographic on films that have been seen by over 100 million people. But he wasn't filming that fateful day in Monterey Bay. He decided to leave his cameras at home, and it was a decision he'd come to regret. Because once he was safely back on shore, he realized, who on earth is going to believe that a whale jumped on me? But luckily for Tom, someone on a nearby boat filmed the whole thing.
The videos went viral, and our lives were turned upside down. Scientists who analyzed the recordings told us that we'd survived because the whale had seen us mid-flight and turned away.
It turned mid-flight?
I know, it's incredible. And figuring that out wasn't the only thing scientists were able to discern from the video.
A citizen science platform called Happy Whale used artificial intelligence, or AI, to match the whale's tail into a new global database launched 2 weeks prior to our incident, and told us who the whale was, how old it was, who its mother was, where it was born, and we have been able to follow its life ever since. If the whale had leapt onto us a few years earlier, before cell phones with video cameras were everywhere, before fast internet was most places, before AIs had been trained to find patterns in whale lives, then my story would have ended as soon as it had begun. a near miss, and an exhilarating experience, unwitnessed and likely unbelieved. But instead, tens of millions of people watched a video of a whale that changed what they thought whales could do, and layers of meaning and connection could be followed from it into a much bigger story.
That bigger story is this. Recent technological breakthroughs have transformed our understanding of animals. Think back to the 1830s when Darwin sailed around the world on the HMS Beagle.
He could only perceive what his senses could perceive. He could only go where his body could go. He could only share what he learned with a few others who read his writings. And he could only record in words what he had witnessed.
Darwin had to rely on what he saw and what he knew. Imperfect tools. When he discovered his famous Galapagos finches, he didn't think they were very special. He actually misidentified them. It wasn't until he got back to England and showed the specimens to an ornithologist that he realized these birds with their diverse beak shapes could be a powerful piece of evidence for his theory of evolution. So that's what it was like to be a naturalist in the 19th century. Today,
you can buy an AI bird feeder that identifies the individual birds that visit your garden and sends its sightings to the cloud automatically.
That may sound like a gimmick, but Tom says it's an example of the new tech that's transforming biology from the study of bodies to the study of the previously uncapturable.
Behaviors, movements, interactions, and communications. Machines have transformed the ability of biologists to perceive and record the living world, and what they have seen has transformed our understanding of the lives of other animals.
And nowhere is that transformation more apparent than with the scientists who are trying to build a Google Translate for animals.
This is the sound of a group of Pacific white-sided dolphins. There are so many voices in the recording, it's impossible for the human ear to tease them out. But new machine learning tools can separate out the voices and identify each dolphin by its signature whistle. A great hurdle for animal communication studies has always been the innate problem of the human observer. We cannot be watching all the time. We cannot record and remember everything. We cannot perceive patterns in their communications, apart from very basic ones that relate to our own. Where we have failed to find evidence of complex communication, or figure out what it means, we've assumed it isn't there, and blamed the animals at failing our tests. And so we've decided that other animals don't have something like language. But this seems hasty, and in the light of our track record on other things we used to think only humans did, perhaps foolish. Machines are changing all of this. Google Translate can switch between English and Urdu and Swahili without a bilingual or trilingual dictionary. It works because AIs have discovered hidden deep patterns and relationships within human language that we could not perceive before, and use these to translate without a Rosetta Stone. Could these pattern-finding tools find patterns in the communications of other species? A Google Translate for animals? Several teams are already trying. Right now, off the waters of Dominica, the seas are being rigged with the most sophisticated animal listening system ever devised to capture the entire vocal lives of the resident sperm whales. It is called Project SETI. Hydrophones will float at 100-meter intervals. Soft robotic fish will swim among the whales, recording their lives. The sperm whales themselves will carry recorders. The team aims to gather the largest animal behavior dataset of all time. This is big animal data. They are designing this dataset specifically to feed into their pattern-hunting AIs and attempt to crack the codes. By listening to the lives of the whales, including young whales learning to speak, they plan themselves to piece together the rules of sperm whale speak. Then they hope to have a two-way conversation. They want to make contact. They are aiming to do this in a matter of years, and whales are just the start. What would this mean? Why are they doing this? Which brings us onto our final big idea, the power of empathy. These are the sounds of humpback whales. These ones are from Monterey Bay, where I was landed upon by one of them. Perhaps one of these voices belongs to the very same whale. When I was born in 1983, we were slaughtering these and other whales in their hundreds of thousands, and if we had continued, the seas would likely no longer ring across the world to these beautiful calls. It was in the midst of the carnage of commercial whaling over half a century ago that Dr. Roger Payne was given a recording of these sounds from the waters of the Bahamas. He called them rivers of sound. By careful analysis, he realized that not only were they made by whales, but that, in his words, by God, they were repeating themselves. They were made up of repeated patterns similar to notes, phrases and themes, refrains and choruses, even rhythms and rhymes. When he proved that whales were singing, it made the front cover of Science. When he released an album of the recordings, it sent shockwaves through human culture. People reacted powerfully to these songs from the ocean. They became a phenomenon, played on television, in concerts, shot into space on the Voyager space probes. That whales were like us in how they used their voices triggered an explosion of empathy that propelled the campaign to cease their slaughter. Whales today, thanks to this, are largely safe from whaling, but face warming, acidifying, overfished and polluted seas. They're run over by our boats, deafened by our sonar, fatally tangled in our nets. Roger is one of the lead scientists of Project SETI, one of the teams trying to translate whale communications. What all the teams have in common is the hope that by decoding whale speak and the communications of other species, we might trigger another great change of heart. Our relationship with nature is in a bad state today. As a conservationist, I know from experience that people are mainly motivated to protect those they can empathize with. I am compelled by Roger's logic. It's hard not to imagine that if we could understand what whales and other animals were communicating, if we could see vividly what they cared about, their joys and pains, that it would not change us. And the ramifications are wider than conservation. We have long clung to our specialness. Would we feel challenged by what we learned? How should we safeguard the power that this new knowledge would give us and not use it to manipulate and exploit? If you discovered what your cat really thought about you, would your relationship survive intact? These are intriguing questions, and I hope that now with a taste of the exciting frontiers explored in How to Speak Whale, you do not find it absurd that I suggest you take them seriously.
Cisco, come! Hi, can you sit? Can you sit? Good girl. What do you really think about me, Cisco? Oh, do you want a belly rub? Oh, okay. Oh, that's a good girl. Oh, I love you too.
Thank you to Alexandra Horowitz, James Bridle, Justin Gregg, and Tom Mustel. To hear their book bites and hundreds more, all you have to do is download the Next Big Idea app. You can read a book in just 12 minutes or listen. Read fast, think big. Download the Next Big Idea app right now. Today's show was written and produced by Caleb Bissinger. That's you, Caleb.
That is. Our executive producer is Michael Kovnat. High five to Eric Ramirez, our Senior Director of Audience Development, who came up with the theme for this episode. Editing by Ioannis Kalanitzis. Sound design by Mike Toda.
The team at the LinkedIn Podcast Network already knows how to speak whale. I'm your host, Rufus Griscom. See you next week.